You see that it's telling it all of them are now generic. It's going to quickly do the same thing for our queue. And so our queue also is going to be now a generic type queue. And so we're adding the E type into it. So when you're creating, you have to specify that. Let's go all the way and do this to our stack as well. And accepting the type and even searching for that. So that's it. We did it. Now we're gonna go test those two as well, just to be sure we're not really messing up anything. So I'm gonna test the stack and queue together. Oh my goodness. Sorry about that. I'm trying to do things faster. Okay, there you go. Now we have a couple of errors here, and that's because we have to make the type, specifying the type. So we're going to make all of them string here. So now that all of our test cases is going to work. So perfect. So not no error, no compiler error, no runtime error, and we created all these generic type data structures. Another thing is nice to do, and I like to do it really quick, and I want you guys to do it, is that create an list interface or abstract class. Actually, I'm going to make it as an abstract class. Sorry, I'm going to make it as an interface. You could maybe also create it as an abstract class, and I'm going to call it my list. So what I have in the list, what I want to add in the list, my list also going to be generic too. And what I want it to be in this list, I want it to be everything that's common between all of these lists that I have. So for example, all of these lists are going to have the public method for telling me that it's empty or not. They're all going to have a search method. They are going to have a print method, for example. No matter what type of list it is, there are some common behavior between all of them. So I want to find those behaviors common, and I would like to put them in the, so here into this list. So we have this size method, for example. We like all of them to have the size method, or the at first. This is going to help us to be more basically more consistent. So later on, when I created another type of list, then at least I know the basics and method and basic information I want, or basic behavior, right, that I want for my list to have. We added already this print and everything. So I guess uh, we have everything that we would like to have. So now that I have this generic list, I could go to all of these lists that I have here, and I'm going to say that implements my list. So this way, if I miss any of this method, it's going to tell me that you missed it and force me to implement it. And also I can add this override on the top of them in case they're not exactly matched with the implementation is going to tell me, like if it's is empty, it doesn't have capital E, it's going to tell me that you're not really overriding the method of the pass my list. So I'm going to do the same thing for linked list and array list, sorry, two. You see now here we have an unimplemented method. Let's see, what is that? The search method that we had or we originally implemented inside the array list, we call it, we're returning an integer type. So this is used internally in some other classes that we have. So we can make this one actually private because nobody else is going to call this. And then we're actually going to implement this other method that is going to return if the value that is going to be returned is bigger than or equal to, or basically it's not -1, then we're going to return so okay, another very good point here is that the methods here that we have, they have exact same signature, they have exact same list of parameters, but the only different thing is return type. One of them is Boolean type and one of them is integers type. So this is the only difference between these two. And usually we're basically going to have to compare when you're returning in a particular value like that. So we call it compare. So I have to change the name as well. And that's a very important thing to remember, that the method signature, the return type, is not part of the method signature. It's part of the method header, but it is not the part of the method signature. And for method overloading, right, to have the method with the same exact name and list of parameter, different list of parameter, you need to have really this different list of parameter, not just the return time by itself. So that's why we got the error. So we're changing that to compare it to, and now this has become our linear search method that we had. Basically, they do the same thing, but we can later on change the compare to method to really give us a better, numbers. We're gonna, we kind of talk about the comparable interface. So if we implement comparable interface, that's something that we can work on it. But anyways, I just wanted to say that we can have the same exact method. So here, add first and remove first, we probably have the same thing here as well, but we just don't have the same name for them. So add first and remove first. I have the same thing, add first, remove first. Remove, it's looking for a particular parameter, and then it's going to, if it find it, going to return it. It potentially can be returning, removing from the first, but it's not really removing first, right? So to solve that problem, what we can create is to create a specific uh, remove method that accepting the, so this is add first, sorry. Here's the add first that we had. Right there. So this add first is really just adding, right, in a particular index. It's basically not always going to be in index 0, but this one definitely means adding things to index 0 because I want to add it to 0. So we can just directly say index 0. So it's going to call this one, and it's going to act the same thing. And the same for the remove. Change the name to compare to, and same for the remove, right? So I remove first, it's really going to remove the one that is index 0. What we have here as remove first is not really a remove first, right? So what I have to do is to just call the remove first that we have, and we have to get the element at index 0 and return it to it. So that's going to help us to have the same public interface as as our list, but then we also have some extra. So it's all of our methods. All of our classes are going to be look like each other as far as like parameters and everything that they have, because they're all considered lists, right? So that's also something I wanted to add basically. And so you see this is also generic, right? So it has all these e's in it, so it's going to do the type checking for us. Okay, so we talked about this concepts of generic as well. So please, again, if you have any questions, uh, please use the discussion board to ask your questions. Discussion board is going to be a very good source for also our, not only our communication, but also as far as the participation in the class, since we don't have attendance anymore. And so it's very great opportunity. Also, the assignment for this generic also going to be available and in class, consider in class assignments. So you want to do same things we did with all of your list and submit it into the assignment, generic my list assignments into the e-learning. Okay, guys, thank you so much. And next topic is going to be the different sorting algorithms that we're going to talk about it. Again, stay safe. Bye.